Hey everybody, welcome to another installment of your virtual classroom. Tomorrow we're going to be playing with magnifying glasses in class, and so I wanted to prepare you guys to do that. We need to be able to investigate the relationship between image and object distances and some properties about those images and objects. So today we're going to do ray tracing with convex lenses. Remember, convex lenses are converging lenses. It's the same thing. And ray tracing is a tool that's going to help you be able to determine the properties of an image, its size, its location, whether it's upside down or not, based on the position of the object. You'll need a pencil and a straight edge for today. And remember from yesterday we talked a little bit about lenses. Convex lenses have two focal points, one that we call the in focal point and one that we call the out focal point. Let me find my mouse here. In and out. And remember where those focal points came from are rays that are traveling from infinity. So if we have a source at infinity, those rays are coming in parallel and converging to the focal point. What we're going to do today is look at where the rays converge when they come from somewhere closer than infinity. This manifests itself in 5 qualitative regions. So let's see sort of what I mean by that. If I've got, this is my principal axis of my lens, and this is my lens here. If this is my focal point, F, and this is my focal point, F, we double that. This would be my 2 times the focal point. Remember, that goes for either side. And our 5 qualitative regions are, how do I denote this? We've got one that's outside 2F, one that is at 2F, one that is between F and 2F, a region at the focal point, and a region inside. So I guess we call this region 1, region 2, 3, 4, and 5 for where the object is placed. And we're going to see what happens to the image when the object is in one of these 5 regions. After we go through the 5 regions, we're going to take a trip to the university and see a demo. And finally, you'll get to play with a simulation to explore these regions on your own. So let's get started. When we do ray tracing, we work with the principal rays. There are some other types of rays called marginal rays, which have to do with the lens. The marginal rays go through the center and top and bottom of the lens. The principal rays are easier for us to do ray tracing because we can draw them parallel to the principal axis of the lens. So our 3 principal rays are in parallel, that's this first top ray, and it comes out through the focus, remember the F out point. Our second is in through the in focus and then out parallel, and our third goes in the center, out the center. And where the 3 rays converge is our image. So let's go through the 5 cases. This is where you'll need your straight edge. It may help to have some colors. Let's just go right along and we'll see how it works. So what are the 3 rays? We start from the tip of our object. Now, I could just as well start at the center of the object, and where the rays converge would tell me the center of the image. But we use the tip because it's the most extreme point of the object, and it will tell us where the tip of the image is, and then we can draw the rest of the image back to this thing. So let's start at the top, and we go in parallel, out focus, so down through the focal point. Our second ray goes in through the focus, the first focal point, to the center of the lens, and then out parallel. And then our third ray just goes from the tip of the object through the center of the lens and straight out again and lo and behold, they all meet up at a point. I'm going to draw an arrow here to represent my image. Now, I want to be clear that this arrow is not pointing at the, make it a bit thicker, make it a little bit thinner. This arrow is not pointing at the place where the rays converge. This arrow is my image. Just notice our object is also an arrow. So I'm not just indicating where they're meeting. That's the image. Always draw the image. We can look at the properties of this image. It is inverted, upside down, so we call that inverted. It's reduced because it's smaller. And the fact that the rays converge in a real place means it is a real image. Great. I would like you guys to make a prediction for case 2 of what. So good. Tomorrow we're going to play with all of these cases. Hopefully you've got all those down. Certainly come with questions tomorrow. And so now let's take a journey to the university for a demo. Okay, whoa! They warned me that my clothes might change in genie school. To make sure I get my clothes back. Okay, let's see some demos. Welcome to the demo room at the U of O. Hello, Jesse, in the distance, doing a fine job. I have here the word physics written on a sticky note. Notice when I'm outside the focal point, the focal length of this magnifying glass, what do we expect our image to be? We said it was going to be real, size varied, but inverted is something that we noticed. And so here we are outside the focal point, and the word physics is upside down. And as I moved closer and closer, what did we know happened? We lose the image at the focal length, and then it becomes upright. There's some more physics going on than I care to talk about now because there's also a lens in the camera. What you're seeing here is a virtual image. What you're seeing here is a real image. But that's a talk for another day. Basically, we get to see that it's upright and not upright. And so now here's one more setup I would like to show quickly. Notice I have a light bulb, a lens, and a screen. So this light bulb is my object. I've got an arrow drawn up and a circle drawn to the right to give us an idea of orientation. This is a lens with a focal length of about as big as my hands, from pinky to thumb. And the screen here is my image. So I'm going to back you guys up and turn on this light and turn off this light. And you can't exactly see it here, but I've got the image focused on the screen here. So object is outside 2F at this point, and my image is focused here on the screen. It's inverted and flipped left to right as well. So what happens is I bring my object in closer to the lens. Which way does my image move? How does it change? What happens to it? Hiya, Dean. So I'm going to bring my object in. Let's bring the object in maybe 6 or so inches and see if we can't focus the image by moving the screen. So there we go. There it's about focused. I know it's bright with the camera screen, but there you can see it now. And if I bring my object in even closer, image goes out of focus until I move the screen to bring it. Oh, I think I moved a little bit too close. There we go. So there's a good and sharp object. A good and sharp image here from my object back there. As I get closer and closer to the focal length of the lens, and when I'm at the focal length of the lens, the rays are coming into the lens and traveling out parallel. Remember, we saw that they don't focus because they're coming out parallel. And then what happens when I get inside the focal length? Well, at that point, we have a virtual image that you cannot project onto a screen. But if we look closely, here is the light bulb. And as I bring you in, looking into the lens, you see a much bigger version of the light bulb. That's just the very corner of the light bulb that you're seeing there. There's the actual size, and here comes a blown up light bulb, like we would expect looking into a magnifying glass. Okay, so we've got one more thing for today in your screencast, so we're going to go back to south, and I'm going to make sure to put my clothes back on. Alright, that was fun. Welcome back. What I'd like you all to do now is navigate to the PhET simulation page, and this will conclude this iteration of your virtual classroom. But here is the link that I can hopefully put in, it will work, and then where you will end up going is to this simulation. Okay, you can also Google for it, PhET optics, and it will be the first hit that shows up, and you can just click run now. We've used the PhET simulations before, so you shouldn't have any difficulties. I think we've probably worked all of those out by now. But once you get into the simulation, notice here I've got some options. I've got no rays, marginal rays, principal rays, and many rays. I'd like you first to explore the principal rays because it's what we've been talking about. And what you can do in this is move the object around and see where the image is. They note the focal point. You can click virtual image as well. You can change properties of the lens if you like. I'd like you to explore the many rays option, and I would also like you to explore the second point option because that shows you that rays can come from anywhere, and they still give you the image. So go ahead, play with all of those things, go through the 5 qualitative regions, and you will see everything that we just did, and it's quite fun to play with. Anyhow, with that, I leave it to you to do some exploration, and I will see you all in class tomorrow. Have a great night.